Hi viewers! In today's video you are going to look into Rhino Cave origins, the influence of lava. Preserving fossils is crucial for their preservation, and volcanic activity can be the key to preserving some incredible fossils. One example is the Ashfall fossil beds in Nebraska, which has uncovered hundreds of fossil skeletons of rhinos, camels, tortoises, and other animals preserved in a massive deposit of volcanic ash. The ash was not from anywhere in Nebraska, but came from a volcanic eruption 1,600 kilometers away in what's now Idaho. The ash was not just buried, but it killed the animals by breathing in toxic particles that caused respiratory issues. The order of the animals' deaths can be determined by looking at the layers of the ash. Small animals like birds and turtles are buried deepest, meaning they died first, while medium-sized animals like horses and camels survive longer due to their larger lung capacity. At the top of the deposit are the site's biggest animals, the rhinos. Over 100 rhino skeletons have been found at Ashfall, and some skeletons are preserved in 3 dimensions, exactly as they would have been when the animals were alive. Volcanic ash can also preserve footprints, such as the famous Laetoli footprints discovered in Tanzania in the 1970s. Paleontologists have found thousands of footprints at Laetoli, preserved in 3. 6-million-year-old ash deposits. These tracks were left by various animals, including elephants, giraffes, birds, and insects. The most famous feature of the Laetoli ash beds are footprints that look a lot like yours and mine. Researchers discovered about 70 footprints left by human ancestors, most likely made by Australopithecus afarensis, which is the same species as the famous Ethiopian fossil called Lucy. The Laetoli footprint site is like a layer cake of preserved trackways. When volcanic ash reaches areas far away from an eruption, it can also preserve cool fossils. Pyroclastic flows, which are avalanches of superheated ash, gas, and rock that cascade down the slope of a volcano, can reach temperatures over 800 degrees Celsius and move fast, making it difficult to get in the way of one. However, on rare occasions, pyroclastic flows can also preserve cool fossils by creating deposits called ignimbrites. A vulture's head was preserved in a cave by a pyroclastic flow that enveloped it, preserving its shape, tongue, eyeballs, and transparent third eyelid. This unique pyroclastic preservation is similar to what happened at Pompeii, but with more detail due to the cooled ash flow. Blue Lake Rhino, located in Washington, is an unusual cave that contains fossil rhino bones. Researchers discovered the cave in the early 1900s and noticed something unusual about the cave itself. It turned out to be an impression of a rhino's body, preserved thanks to flowing lava. The rock in this site is pillow basalt, which forms when lava touches water and cools quickly. Around 15 million years ago, lava flowed into the water, enveloped the rhino, and cooled into solid basalt. Eventually, the rhino's soft tissue rotted away, leaving behind a rhino-shaped hole. Researchers believe that the rhino was already dead when it became engulfed in lava, and might have been bobbing in the water until the lava flow came along. Other log-shaped caves nearby are thought to have been made when the lava hit trees floating on the water. Dinosaurs' footprints have also been found in magma. At the Jindong Formation in South Korea, there is a layer of igneous rock from the Cretaceous period that contains footprints belonging to sauropods, specifically the Brontosaurus type of dinosaur. Some of the footprints are up to 3 feet long. Paths in magma might sound strange because animals can't walk across molten rock, and magma is molten rock underground. These dinosaur footprints are preserved in a sill, a horizontal band of igneous rock formed from the underground flow of magma. The animals walked across mud and left behind their footprints, which then got covered up and filled in by fresher mud. Over time, muddy layers solidified into rock, with footprints on the upper surface of the lower rock layer and natural molds on the upper layer. Magma seeped between these layers, conforming around the footprint casts. Now, even though these are magma copies of the original footprints, they are preserved in immaculate detail, including details of the toes and claws of the dinosaur's feet. Thank you for watching this video. If you liked the video, don't forget to subscribe our channel and leave a comment in the comment section below. Follow us for more to get to know about nature calls.